Dear students, welcome to our class on vegetative indices, monitoring crops. Vegetative indices, monitoring the crops. I request you to subscribe to my channel Agrometrology, Farmers and Rural Development, because in the basics I have taught, I have explained, I have gone basics very deep so far on the indices. I don't want to touch them. This is the advanced one, that means real applications. Okay. Now, in this class we are going to study remote sensing for monitoring crop prospects. Remote sensing for monitoring crop prospects. Remote sensing for crop yield forecast. You see, crop monitoring, crop yield forecast. This is what we are going to learn. Of course, vegetative index already I have explained, NDVI, VCI. Now, how these two are helpful in the monitoring the crop as also yield of the crop. Now, it's very interesting. The first thing is what? Remote sensing for monitoring crop prospects. Now, crop monitoring and yield forecasts are important for food security. The conventional techniques are often subjective, costly, time consuming, and are prone to large errors due to incomplete ground observations, leading to poor crop yield assessment. So, traditionally, we are following monitoring of the crop and yield forecasting. Of course, statistical techniques are there, several techniques are there. Now, we confine ourselves in this class to only remote sensing. This is advanced, real application. Now, what are the disadvantages of the traditional? They are subjective, costly, time consuming. Now, remote sensing is generally considered one of the most contemporary technologies for monitoring the crop prospects. Monitoring means, starting from plant preparation, primary tillage, secondary tillage, seedbed preparation, sowing, intercultivation, fertilizer application, irrigation scheduling, crop, biological, of course, biotic, abiotic stresses, crop harvesting, everything. Okay? For monitoring crop prospect and for the yield forecast. Finally, how much yield is at what stage? Even at the middle of the stage of the crop growth, we can forecast the yield through remote sensing. How? By using these two in this class, with the advanced what we are going to learn. Now, see, it can monitor, remote sensing can monitor many crops and vegetation parameters through images at various wavelengths. Remote sensing offers the possibility of obtaining the data in exactly reverse of the conventional, easy, fast and appropriate and profitable way, okay, of crop monitoring and yield forecasting. Now, processing at, now let us see remote sensing for crop yield forecast. Processing at, of course, the different vegetative stages, okay. Processing different vegetation indices has been associated with physiological parameters of the crop such as plant pigments, vigor, aerial biomass, yield estimation, and plant physiological stresses. Okay, now, so let us go to the information provided by remote sensing allows obtaining yield data at a lower cost compared to other methods. The coverage of large areas and possibility of periodic repetitions. Through remote sensing, we have large areas, no boundaries at all. Several types of images can be used to monitor the agriculture crops. In large cultivated areas, data from low spatial resolution satellites are suitable. Where plots are small, use of very high resolution, very high spatial resolution data may be necessary. However, the temporal resolution of these satellites and the possibility of clouds during their process are sometimes, of course, a small bottleneck or limitation. Okay, that's much. That we are going to overcome it through very sophisticated technologies. Now, various studies have been conducted for the yield forecast across the world to predict the crop yield using both optical and microwave remote sensing data. Vegetation condition index. Several times I told NDVA, normalized difference vegetative index. Several times I told. I am going to discuss very little or one or two lines on this, but VCI, vegetation, okay, condition index, VCI, okay, is an indicator of the vigor of the vegetation cover over a larger area. It is a function of NDVI minima and maxima for a given land area. It normalizes NDVI, normalized difference vegetation index, further normalized by vegetation condition index VCI, okay, according to its average over many years, and results in a consistent index for a different land cover type. Any land cover it will cover. So if the data are recorded over long periods during where extremes okay, in climate or experience, the VCI indicates the potential of the crop. Extremes, completely drought, excellent rains. Okay, in both these situations, VCI, vegetation condition index, give the yield forecast, and we can monitor the crop also. So it is highly correlated with the crop yields and hence able to accurately track the yield loss. Particularly in India, rice crop yields, vegetation condition index has predicted up to 90% probability, 90% positive. Okay. The coefficient of variation is 90%. Now, see NDVI formula I have already done, NIR minus R by NIR plus R. So, NDWI, okay, normalized difference water index is NIR minus SWTR by NIR plus SWTR, as I told several times in previous classes. Now, what is VCI? This is what VCI. Indices corrected minus indices maximum by indices maximum minus indices minimum is the vegetation, okay, condition index. Now, vegetation condition index is proved to be very successful under Asian conditions. It has given wonderful results as far as particular rice is concerned. So, these studies amply proved that information on crop yield derived from remote sensing is very useful for decision making and planning all agricultural activities. Now, the summing up in one line, crop monitoring and yield forecast of the crops through vegetative indices in remote sensing is very easy, less cost, and then more accurate. But however, in the previous lectures I have compared both remote sensing and traditional methods as a combination also will work a lot. Thank you very much for your patience.